Okay, in the chapter the triangles and its properties, there is one very good example on this page here, that is this. An exterior angle of a triangle is equal to the sum of its interior opposite angles. So I'm going to explain it here. So if you see this diagram, this is one triangle ABC, and I have already prepared this diagram, and this line CE is going parallel to line AB. So we have to prove this, that an exterior angle of a triangle is equal to the sum of its interior opposite angles. So if you see this triangle, what is the exterior angle here? So sum of x plus y, these two angles, is equal to the sum of opposite interior angles. It is equal to angle 1 plus angle 2. So this is what we have to prove here. So I have already divided these two angles with a parallel line. That parallel line is CE. So here CE is parallel to AB, and I have extended BC till D. Okay, so that we can actually define this entire exterior angle as x plus y. Okay, now moving further, we have to prove that this angle is equal to this plus this. Okay, now if you see this angle x is equal to angle 1. This angle is equal to this. How and why? Because if you see this AC is a segment that is basically a transversal segment. And what is a transversal segment? Where this segment is touching and dividing or touching at more than two segments. So one segment is AB and one is CE. So if you see, this is touching and dividing this segment and this segment, and then it's forming a angle. So it's dividing and touching AB and CE, and that is why the opposite, that is the alternate angles. So if you see, these all are the alternate angles. Angle x and angle 1 is alternate angle, and this will be equal if it is being divided through a transversal segment. So AC is a transversal segment, so these two angles are alternate angles, and alternate angles are equal. Okay, now again, if you see this segment BD is again a transversal segment, because it's actually crossing these two lines, right? So that is why these two corresponding angles, angle y and angle 2, so that is why angle y is equal to angle 2. So these are the corresponding angles. These are on the same face, and these are on the opposite face, right? So these two are the alternate angles, these two are the corresponding angles. So from this you see angle x is equal to 1, angle y is equal to 2, this y is equal to 2, and this is equal to 1. So angle x plus angle y is equal to angle 1 plus angle 2, that is what? ACD, angle ACD. And what is this angle? This is angle A plus angle B. So this is what we had to prove, that this entire angle, that is the exterior angle of this triangle, is equal to the sum of the opposite interior angles. So these are the opposite interior angles, angle A and B, and this is angle ACD. ACD is the exterior angle of this triangle. So this is what is proven. So what have we noticed here is the transversal segment and the alternate angle and the corresponding angles. So we have to understand these three concepts. So what is the transversal segment? Where a segment is actually touching and dividing more than two segments. So AC is a transversal and BD is a transversal, and these two are the alternate angles, right? Alternate, and these two are the corresponding angles. Okay, through this transversal segment, y and 2 are corresponding, and x and 1 are alternate through this transversal segment.